Picture a rock, just a plain, boring rock. It's sitting in the dirt. It's been sitting there for billions of years. It's dull, it's kind of a rusty reddish brown. It's heavy, and honestly, it looks like nothing, like a clump of hard mud, like the ground itself. Farmers walked right over it. Kids kicked it out of the way. Builders used it to plug holes in walls. Nobody gave it a second look. But hidden inside that ugly little rock was the stuff that would one day hold up skyscrapers, carry trains across whole continents, build the ships that cross our oceans, and get hammered into the machines that pulled humanity out of the mud and into the modern world. For most of history, though, it just sat there, doing nothing. So here's the real question. Not just how we found this metal, the deeper one, the one that'll change how you look at every bridge and building you've ever walked past. How did some ancient person with no chemistry, no science class, no textbook, nobody to teach them, stare at a dull red stone and somehow pull metal out of it? Metal that Stone Age tech had no business making. The answer is one of the wildest stories we've got. And it doesn't start underground. It starts in the sky. Real quick before we dive in, if you love this kind of story, the how did they even figure that out kind, do me one tiny favor. Hit that subscribe button. Seriously, it's free, it takes 1 second, and it's the single biggest thing that helps this little channel keep making videos like this. And if you're enjoying it, drop a like too. Okay, let's get into it. To get how insane this discovery was, you've got to understand the world before it. For nearly 2 million years, human tech ran on one thing: stone, flint, obsidian, rocks you could chip into a sharp edge. And look, stone worked. You could cut, you could scrape, you could hunt. But stone is brittle. One bad swing against a bone and crack, it's shattered. And once it broke, done. You couldn't fix it. You started over. Then, about 5,000 years ago, something changed. People figured out copper. And this was kind of a miracle. They realized certain greenish rocks, if you threw them in a hot enough fire, would ooze out a soft, shiny liquid metal. And that metal hardened into whatever shape you wanted. But copper's soft, way too soft. A copper blade bends instead of cutting when it hits something tough. So they found a fix. Mix copper with a little tin, about 9 parts to 1, and boom, you get bronze. Harder, tougher, a real upgrade. And bronze ran the world for almost 2,000 years. Bronze swords, bronze plows, bronze everything. The first cities, the first writing, the first empires, all built on bronze. But bronze had a nasty little catch. It needed 2 ingredients, and one of them was a huge pain. Copper, pretty common, but tin is rare. It only shows up in a handful of spots on the whole planet. Bits of Britain, Central Europe, Central Asia. That's basically it. So if you're a civilization in Egypt or the Middle East, getting tin meant running massive trade routes across thousands of miles. Ships hauling tin across the sea. Caravans dragging it over deserts and mountains. And those supply chains? Fragile. One war, one broken deal, one storm that sinks the wrong ship, and suddenly your whole empire can't make its most important tool. Here's the kicker. The one thing that could have fixed all of it was sitting right under their feet the entire time. They just had no clue. Iron is everywhere. It's the 4th most common element in the Earth's crust. It's more than 5% of the ground you're standing on right now. It's in mountains. It's in rivers. That reddish color in a lot of soil, that's iron. Basically rust mixed into the dirt. There's almost nowhere on Earth you can't find iron. And yet, for thousands of years, people who built pyramids and wrote laws and made gorgeous bronze couldn't do one useful thing with it. Why? Because iron on Earth almost never shows up as actual metal. Gold? You find shiny gold nuggets in rivers. Copper? Sometimes you find raw chunks of it. But iron? Nope. Iron loves oxygen. Like obsessively. Leave iron out in the air and water for a few thousand years, and it turns into rust, into dull red stone. So when an ancient person looked at iron ore, they didn't see hidden metal. they saw a red rock, a heavy rock, a rock that looked exactly like a rock. Because as far as they could tell, that's all it was. But there was one exception, and it came from space. Some meteorites are chunks of the metal cores of old asteroids. And when one of those falls to Earth and survives the trip, it brings something that basically doesn't exist naturally on our planet's surface. Pure, usable iron, already metal, mixed with a bit of nickel. And these space rocks are weird, way heavier than normal stone. They're magnetic. Hit one with a hammer and it doesn't crack. It dents. Cut it and it shines. Everything about it screams, this is not a normal rock. Ancient people noticed, instantly. In Egypt, they had a word for iron that literally meant metal from heaven. That's not poetry, that's a description. The only iron they'd ever touched really did fall from the sky. The Sumerians did the same thing. So did the Hittites. Black iron of the sky. Different cultures, thousands of miles apart, all landing on the same idea. And we've got proof. Some of the oldest iron objects ever found, little tube-shaped beads from an Egyptian grave over 5,000 years old, test-loaded with nickel. That's the fingerprint of space iron. And King Tut? Buried with a dagger made from a meteorite. The king of Egypt went into his tomb with a blade forged from a rock that fell from the sky. Back then, this iron was rarer than gold, worth up to 40 times more than silver. It was a gift between kings. But that sky iron? That's not the iron that changed the world. To unlock that iron, they needed something that didn't exist yet. They needed a whole new kind of fire. Here's the fact that held everything up. Copper melts at about 1,085 degrees Celsius. Bronze, a little lower. And Bronze Age furnaces, they could hit those numbers no problem. Perfect. But pure iron? It melts at 1,538 degrees. That gap, around 400 degrees, sounds small. It is not small. It's a completely different league. Those old furnaces, no matter how well you ran them, physically could not melt iron. And we know people tried. They tossed iron-rich rocks into their copper furnaces and waited for liquid metal to pool at the bottom. And nothing. The iron just sat there, red hot, stubborn, solid, giving them nothing. So of course everybody figured iron's a useless rock, because based on everything they knew, it was. Turning that rock into metal needed a trick nobody had discovered yet, a way to pull the metal out without melting it at all. And here's the beautiful part. Nobody planned this. It happened by accident, one improvement at a time. First, charcoal. At some point, metalworkers stopped burning plain wood and started burning charcoal, which is basically pure carbon. It burns hotter, cleaner. It cranked up the heat. Second, enclosure. They started building tall clay and stone furnaces instead of open fires. And a tall furnace acts like a chimney. Hot air rises, sucks fresh air in from the bottom, and that extra oxygen makes the fire burn even hotter. They didn't know why it worked. They just noticed taller furnaces burned better. Third, bellows. Leather bags that pumped air straight into the fire, and that forced air pushed the heat way up. Now, here's the thing. None of these people were trying to make iron. They just wanted hotter fires for their copper and pottery. But add it all up over a few centuries, and they'd accidentally built a furnace that could do something they never intended. So one day, probably nobody even noticed the exact moment, a copper smelter tosses some iron-rich rock into one of these hot, charcoal-fueled, bellows-pumped furnaces. And the iron doesn't melt, but something else happens. That charcoal, burning with limited air, gives off a gas, carbon monoxide. And carbon monoxide is hungry for oxygen. As it rises through the furnace, it hits the iron ore and rips the oxygen right off it. It doesn't melt the ore. It chemically transforms it into actual metal while it's still solid. And what you get at the bottom isn't a pool of shiny liquid. It's a lumpy, spongy, ugly mass of iron bits fused together with glassy junk. It's called a bloom. So somebody cracks open that furnace, expecting garbage, And instead, they find this dark, porous blob. Doesn't shine, barely looks like metal. But they smack it with a hammer while it's hot, and it doesn't shatter. It bends. It squishes. It's metal. Something brand new was in the world. But that raw bloom, not usable yet. It's full of holes and junk. Leave it alone and it'd crumble. So the blacksmith gets to work. And it's brutal work. While that bloom is glowing white hot, they hammer it hard, over and over. Each blow squeezes out the junk, closes up the holes, and smashes the iron bits together until they fuse into solid metal. No melting needed, just heat, muscle, and a hammer. What comes out is wrought iron, tough, bendable, shock-absorbing. And best of all, it didn't need tin from the other side of the planet. But iron still had one secret left. See, raw iron is tough, but it's soft. An iron blade goes dull fast. Good bronze actually held an edge better. The fix? Carbon. And ancient blacksmiths had no idea carbon even existed. But they noticed something. Iron left sitting in burning charcoal for a long time came out harder, stiffer, better. They didn't know why. They just knew it worked. Here's the secret they couldn't see. When iron gets hot enough, tiny gaps open up between its atoms, gaps the perfect size for carbon to sneak in. And as it sits in that charcoal, carbon creeps into the metal, just a tiny bit, less than 1%. And suddenly, iron becomes something way stronger. It becomes steel. And steel's got a superpower. Heat it right, then dunk it in cold water, and it locks into a super hard form that can scratch and cut bronze like it's nothing. Ancient smiths figured out how to do this. Long heating, specific dunking. They had the recipe down cold. They just had zero clue there was an invisible element doing all the magic. For a while, iron was still second string. Bronze had the reputation, the trade routes, the prestige. Iron was around, but it wasn't running the show. Then, disaster. Around 3,200 years ago, in the span of maybe 50 years, nearly every big civilization around the eastern Mediterranean collapsed. Empires vanished, cities burned, and those long, fragile tin trade routes gone. No tin meant no bronze. So metalworkers looked around and asked, what have we got locally? Iron ore, everywhere. No imports needed, just local rock, charcoal, and a furnace. And that's what flipped it. When you have a choice, you pick bronze. When you're desperate, you pick survival. You pick iron. And once Smith mastered steel, iron didn't just replace bronze, it crushed it. Good steel is 2 to 3 times harder than the best bronze, holds an edge longer, lighter for the same strength. But the real game changer was the cost. Bronze needed rare, expensive tin, so metal tools and weapons were basically for the rich and the elite. But iron was cheap. A regular farmer could own an iron plow. A common soldier could carry an iron spear. A little village could make its own metal without buying a thing from anyone. That changed everything. Farming exploded. Armies grew. Power spread out from palaces to ordinary people. Iron didn't just build better tools. It reshaped who got to have them. And here's what's amazing. This wasn't one story. It happened all over. In China, they pushed furnaces so hot they could fully melt iron and pour it into molds, centuries ahead of Europe. They even used water power to run the bellows. In India, smiths sealed iron in clay pots with carbon and cooked it into a legendary high-carbon steel, the stuff of Damascus blades, famous for being both crazy hard and flexible. Europeans couldn't copy it for over 1,000 years. In Africa, smelters built tall furnaces that preheated the air before it hit the fire, a clever efficiency trick Europe didn't formally figure out until way later. Same problem, different brilliant answers, all over the world. So here's where it all comes home. Stand in any city and look up. That building's frame? Steel. The bridge you crossed? Steel. The train, the cars, the pipes, the cables, steel and iron in every direction. And every single gram of it started as that dull, ugly, reddish rock. Every gram went through a furnace where carbon monoxide ripped oxygen off iron oxide. The exact same reaction some confused copper smelter stumbled into 3,000 years ago on a hillside. The scale is millions of times bigger now, but the chemistry, identical. That ancient person who pulled the first bloom out of a fire and realized hammering it made metal, they weren't at the start of some separate little story. They were at the start of this one, ours. If this story blew your mind even a little, the fact that people with zero science figured all this out through pure curiosity and stubbornness, then hit that like button and subscribe if you haven't yet. It really does mean the world to a channel like this, and it helps us reach more curious people like you. Thanks so much for watching. And here's the thought I'll leave you with. Somewhere out there, right now, there might already be another material, something common, something we walk right past every single day, that'll define the next great chapter of humanity. What is it, and how do we unlock it? Well, that story's still being written.